let's take one last look at these changes in energy and temperature. So I've got this equation here, and I've got these problems on the back side of this worksheet that give me the energy and ask me for the temperature change. So if I think about that, what I'm really being given here, we should have already figured out how to figure out what that mass is going to be and what that specific heat is going to be. But we were being given the temperature before, so it was just a straight multiplication, and then we would get our value, our answer. So how is this going to work? Well, let's put a list of variables out here. So remember, I've got E, I've got M, I've got C, and finally T. Oh, I used the wrong colors for that. Nuts. Anyway, so I'm wondering what my temperature change is going to be. And what I'm given is I'm given the energy. That energy, let's use a different, let's do this one. I'm given the energy. The energy in number 7 is 1,000 joules. So 1,000 joules. And then I'm given the mass. It's 10 grams of water. So my mass is 10 grams. And then the specific heat. What is the specific heat of water? I just look back at my table. And water, I've got 4.1813. Let's plug that in. So 4.1813. Okay. So how are we going to put this together? Well, we're just going to plug these numbers into this equation. Let's try that. So I've got E, that's going to be 1,000. And then I've got M, it's going to be 10. Put parentheses around that just to keep everything nice and orderly, times, and then I've got C, that's going to be my 4.1813 times, and then I've got my temperature. So that I used green, then I've got temperature. So how are we going to solve this? Well, this is just going to be some regular rearranging for equations. This is really basic algebra. We should be able to do something like this. The tough part is usually in these kinds of questions is just figuring out where each variable goes. Where do each of these numbers go? But we should be able to figure that out by looking at joules, grams, the substance we're using, and degrees. So we're being asked to find temperature. How are we going to do that? Well, we're going to just do some simple calculations. Let's put these two numbers together. So we're going to have 1,000 equals, then 10 times 4.1813. That's going to be 41.813. So it can be times T. So how do I solve this then? Well, to figure out the change in temperature, now I just need to get this number on this side. So I'm going to do that by dividing both sides by 41.813. So divide both sides by 41.813. And that will give me my temperature. So put it in my calculator here. 1,000 divided by 41.813. That'll give me 23.9. We're going to round to the tenths, so 1 decimal place. For all of these, round 1 decimal place. So I'm going to get a value of 23.9. That's going to be degrees Celsius equals temperature. So I was looking for temperature, and I found that it should be 23.9. So we just rearrange this equation a little bit. We're really just going to take these, multiply them together, and divide our energy by these two numbers. Okay? And that's going to work the same way for all these problems on the back. And then number 10 and 11 are just asking you to look at these numbers, look at this data table, and really think about it. Think about, which substance on the table would take the most energy to heat up. Well, we've been calculating that, so we should be able to go through this and figure out what number is going to make it the most energy. Then for number 11, if I heated up a block of steel, a block of aluminum on a stovetop, what would take longer to heat up? Well, we should be able to look at this and figure that out. Okay. Any questions? Let me know in the comments.